Okay, so welcome back everyone. We are into the third lecture, and this question was given as homework. I'm sure that you would have solved it, and you'd be definitely going to be waiting to check whether what you have done is correct or not, right? So let us start with the first question. Let us generate some space here, right? So first couple of questions, I think there is not much headache. Anybody can answer. So what is alpha plus beta? So again, for my reference, we can mention what is a value. A is 3. What is b value? -2. And c value is 9. And what is b by a value? B by a value is -2 by 3. And c by a value is 3. Right? So what is alpha plus beta? Minus b by a. So answer for this question is going to be 2 by 3. What is alpha into beta? Which is c by a. So we got 3. Now comes the third question. So third part is, what is a square plus b square? So we know that alpha plus beta whole square can be written as alpha square plus beta square plus 2 times alpha beta. Right? Now this is the quantity that you want, isn't it? So what we can write from here? We can write that alpha square plus beta square is actually equal to alpha plus beta whole square minus 2 alpha beta. So evaluate the value. What value will get? So alpha plus beta is minus b by a, isn't it? So which is 2 by 3 whole square minus 2 times alpha into beta is how much? C by a, which is 3. So ultimately how much we got? We got 4 by 9 minus 6, which is 4 minus 54 by 9, which is minus 50 by 4. So the answer for this question is going to be minus 50 by 4. I hope you are comfortable, right? So done. Now let's do the fourth one. So let me put it this way. Fourth one. So what is the fourth one? Fourth one is alpha cube plus beta cube. So generally in the class, I ask that okay, what is the factorization for a cube plus b cube, or how to approach this question. So normally the student says that okay, sir, the way you have written a plus b whole square, in a similar way we can write a plus b whole cube. And then there we can see terms like a cube plus b cube, and then from there we can try to do some adjustments, and then definitely we'll get the answer. Okay, now that is definitely true. Now the other way to do the same question is, you have been taught what is the factorization for a cube plus b cube. So we know that a cube plus b cube is equal to what? A plus b into a square plus b square minus ab. So when you write in this fashion, you know very well that do you know alpha plus beta? Yes. Do you know alpha square plus beta square? Previous question. And do you know alpha beta? Definitely yes. So we just have to feed the value. So alpha plus beta is 2 by 3. Alpha square plus beta square is minus 50 by 4. And alpha into beta is 3. So when we do the calculation, how much we are getting? We will get negative of 2 by 3. 4 3 is 12, so 62 will come. So 62 by 4. This will cancel 2 times, this will cancel 31 times. So ultimately we got minus 31 by 3. So answer for this question is minus 31 by 3. I hope you are with me. Now comes the fifth part. Now comes the fifth part. Now fifth part is very interesting because again in the class the question is 5 minus alpha into 5 minus beta. So if I ask whether students have you got the answer, so they say that yes. And how you have got? So 99% of the cases they get an answer like this. They have opened this and they got like this, and they got like this. They multiplied and they substituted the value. So let us substitute. We got 25 minus 5 times 2 by 3 plus 3. So we got 25 plus 3, 28 minus 10 by 3. 28 3s are 84 minus 10 will give you 74 by 3. So this is again method 1 to solve this question. Now let us see, do we have any alternate way to do the same question? And do. Let us enter. So try to recall. We have been discussing for the last 2 lectures that any quadratic equation ax square plus bx plus c can be written as a times x minus alpha, x minus beta, right? So here what we have? Here we have 3x square minus 2x, 3x square minus 2x plus 9. This can be written as 3 times x minus alpha, x minus beta, right? What are you looking for? You are looking for 5 minus alpha into 5 minus beta. So if I ask you, by seeing these two guys together, what manipulations we should do? What manipulation we should do? So you can see alpha is matching, beta is matching. The only thing is that wherever x is there, I can see, like, if I write 5, things will work, isn't it? So basically what we can do, we can substitute x equals 5. So what we will get? 5 squared into 3 is 75. 5 2s are 10 plus 9 equals 3 times 5 minus alpha, 5 minus beta. 75 plus 9 is 84 minus 10 is 74. So you can see, like, you got 74 by 3 equals 5 minus alpha, 5 minus beta. Now tell me which process was easy, or I can say which process is beautiful. The first one is more or like just calculation based. Second one is like, you can give the wow feeling. Okay, yes, this is something different from the regular method, right? So then I asked the students, what about the sixth one? So let us see what is the sixth question. Sixth one is not this. Yeah. Sixth one is again 1 plus alpha into 1 plus beta. And for your reference, I will just keep it here. I'll keep the entire thing here. Yeah. Now again think. You don't want 1 minus alpha into 1 minus beta. Like when I ask in the class, again students say, sir, we can substitute x equals 1. You can substitute x equals 1, but what will you get? You are not going to get 1 plus alpha. You are going to get what? 1 minus alpha into 1 minus beta. So when I have already asked 5 minus alpha into 5 minus beta, why will I ask again 1 minus alpha, 1 minus beta? Because more or less the process will remain the same, isn't it? So think that what we should substitute. So in case if you want time, pause the video, think about it, and then you can come back. Okay. So here what we are going to substitute? We are going to substitute x equals minus 1. When you substitute minus 1, what will you get? 3 plus 2 plus 9 equals 3 times minus 1 minus alpha, minus 1 minus beta. So now 9 plus 3, 12 plus 2, 14. So we got 14 by 3 equals negative. You can take common, isn't it? So ultimately what we will get? 1 plus alpha into 1 plus beta. So the answer for this question is going to be 14 by 3, and for the previous one 74 by 3. This is 74 by 3. This is 14 by 3. Okay. Let's come to the sixth one. So what is sixth? Sixth is 36 minus alpha square into 36 minus beta square. You can clearly see that. Again ask question, why they gave 36, why they did not give 34, why they did not give some other value. So they don't want to complicate the calculation. So 36 we can write as what? 6 square, and then we can factorize a square minus b square, isn't it? So this we can write as 6 minus alpha into 6 plus alpha. This we can write as 6 minus beta into 6 plus beta. Now above, when we discussed, we very well know that this guy and this guy can be clubbed together, and similarly, this guy and this guy can be clubbed together, because above you have solved 1 plus alpha, 1 plus beta, and above to that you have solved 5 minus alpha, 5 minus beta, is it? So when we do this, we can write like 6 minus alpha, 6 minus beta, and this we can write 6 plus alpha, 6 plus beta. So how to evaluate this? By substituting x equals 6. And how to evaluate this? By substituting x equals minus 6, right? So substitute 6. When you substitute 6, you'll get 3 into 6 square minus 2 into 6 plus 9. And substitute minus 6. So 3 into 6 square plus 2 into 6 plus 9. Here also you can do a square minus b square. You can calculate 6 square is 36 into 3 is 108, and this is 12. Minus 12 plus 9 will give you minus 3. So 108 minus 3 will give you 105. Here we'll get 108, and 6 into 2 is 12 plus 9 is 21. So 21 into 1 plus 108 is 129. Now multiply this, whatever the answer comes, that is the required answer. So I remember my physics teacher used to say this, that if a calculation anybody can do. What is important is that you understand the concept, and after that the calculation you can do, or you can ask your younger siblings also to do. They will be happy doing this 3 digits multiplication. Okay. So that's all was there in that question. Now let us take the next question. The next we have is, they're saying that tell me a quadratic polynomial whose roots are 2 plus root 3 and 2 minus root 3, and some extra thing also they have given, that p of 2 is equal to 5. What they have given? P of 2 is equal to 5. So we know that any general quadratic with the roots as alpha comma beta is given by say it, px equals k times x square minus sum of the root tan x plus product. So let us designate that this is alpha, this is beta. Please tell me what is alpha plus beta? 4. And what is alpha into beta? So a plus b into a minus b will give you a square minus b square. 2 square is 4, root 3 square is 3. So we got how much? 1. So we got k times x square minus 4x plus 1. Okay. But now in case you don't write this k, then you will see like where to use this information. And then you will see like when you substitute x equals 2, you are not getting 5. 2 square is 4. 4 plus 1 is 5. 5 minus 8 is giving minus 3. Right? Then you will start believing that maybe what I've done is wrong. But again, you'll start thinking like, okay, but I know some of the roots only have to do, product of the roots only have to do. So where is the mismatch? So maybe you can think the question is wrong. But in mathematics, question is not wrong. So you can take here what? K. And now you can use the information that P of 2 equals. So when you calculate for 2, this will be K times 4 minus 8 plus 1, and this should be equal to 5. So what is K value? K value is minus 5 by 3. Right? So now what is Px? Px is minus 5 by 3 times x square minus 4x plus 1. So that is the required result. I hope you are comfortable on this. So let us do some more question. So let us do one more question. Let's say that let alpha beta are the roots of the equation x squared plus 3x plus 5 equals 0. Find a monic polynomial or monic quadratic having zeros or roots alpha square mm, alpha square plus beta square, and let's make a change. Let's select 1 by alpha, uh, alpha by beta plus beta by alpha and alpha beta. Means they are asking that alpha beta are the roots of a quadratic. Okay, and those roots, if you try to evaluate, you can see that it is imaginary. Discriminant is 9 minus 20, so clearly it is imaginary roots. So definitely this possibility is not there that we get the value of alpha beta and then we get this quantity and then we evaluate, we generate that quadratic equation, right? So what is the procedure? So procedure is simple, that we will go back to the basics. Basics is find the sum of the roots. So what is the sum of the roots? It is alpha by beta plus beta by alpha plus alpha beta. So when you try to calculate, it is equal to what? It is alpha square plus beta square plus alpha beta whole square divided by alpha beta. Okay. And when we try to get into the product E, so what again we will get? We will get alpha by beta plus beta by alpha multiplied by alpha beta, which is nothing but just alpha square plus beta square. Okay. So now you can see that the only task that is left out here is to get the value of what is alpha square, what is alpha square plus beta square, are the informations directly we can generate. So let us do it here. What is alpha plus beta? Alpha plus beta is minus 3. What is alpha into beta? It is 5. So what is alpha square plus beta square? So we have done above, so I'm not getting much into the discussion. This we can write as alpha plus beta whole square minus 2 alpha beta, which will be 9 minus 10, which is minus 1. So what is S? S is minus 1 plus alpha beta whole square, which is 25 by 5, which is 24 by 5. And what is P? P is just minus 1. So our quadratic is going to be x square minus sum of the roots times x and product. In case if you want to write, this can be also written as 5x square minus 24x 5 by 5. In case if it is, they say it is a, tell me a quadratic equation. So throw this 5 on the right side and we can equate it to 0. So what they have asked, they have just said a monic quadratic. In case if they ask equation, equate it to 0. So you can make it like find a monic quadratic equation. Here we can add equation. So in that situation, what is our answer? Our answer would be 5x square minus 24x minus 5 equals 0. That is the required. Okay. There is a mistake here. What is a mistake? The mistake is we did not use this information. We did not use this information. So what does this mean, Monique? It means that the leading coefficient has to be 1. The leading coefficient has to be 1. So all those things are unnecessary. Okay. We can just leave like this. The quadratic is going to be x square minus 24 by 5x minus 1 equals 0. I hope you are clear on this. So I have used the word leading coefficient. So what does it mean? That if you see a polynomial, right? If you see a polynomial, so you see the highest degree term, the term which is having the highest degree, and its coefficient is called as leading coefficient. Suppose it is written 2x square minus 3x plus 5. It is written 2x square minus 3x cube plus 5. It is written 2x square minus 3x plus 5x to the power 4. So if I ask what is the leading coefficient here, so here the leading coefficient is going to be 2. Why? Because the highest degree term is x square. Here the leading coefficient is 3. Why? Because x cube is the highest degree term, and here the leading coefficient, and here I mean for this expression the leading coefficient is going to be 5 because x to the power 4 is having the highest degree term. Okay, I hope you are clear on this. Okay, so let us go to the next topic. The next topic is difference of the roots. Difference of the roots. Difference of the roots. So let us write here again. Let alpha beta let alpha beta be the roots of ax square plus bx plus c equals 0, where a is not equal to 0 and a, b, c are constants. Then mod of alpha minus beta means what we are calculating? We are calculating the absolute difference between the roots. Why not difference between the roots? See, the point here is, in case you know that one root is 5, other root is 2, and they are asking the difference, right? So you can say that the roots are going to be what? Again, you can ask, isn't it, that which difference you are asking, because we know that subtraction is not commutative. You can't say 5 minus 2 is same as 2 minus 5, isn't it? So since we don't have a very much clarity that whether they want alpha minus beta or beta minus alpha, and also we don't know that which one to call alpha or which one to call beta, isn't it? The interchange definitely there is a possibility. So to avoid all such uh, all misunderstanding, what we can do is we can go with mod of alpha minus beta. Right? So when we try to calculate this, what we'll be getting? We will get mod of minus b minus root d by 2a minus of minus b plus root d by 2a. So when you simplify this, what will you get? You can see here denominator will be c. Here it will be minus b minus root d. Here it will be plus b minus root d. Right? You can clearly see that b will get cancelled, and ultimately what we will get? We will get negative of 2 times root d by 2a. This 2 we can cancel, and minus will be taken care by the modulus. So ultimately what we got? Mod of root d by a. Okay. So for okay. So ultimately what is the conclusion? The conclusion is that the absolute difference of roots is going to be what? Root d by a. And I want you to remember this. I want you to remember this. So let me write here memorize. Okay. Please remember this, that absolute difference of the roots. Let me write it again. That mod of alpha minus beta equals mod of root d by a. This is something I am expecting that you will remember it. Okay. Will remember it. Right. So I hope you are comfortable with that the difference of roots is equal to what? Mod of root d by a. Okay. I mean the absolute difference of the roots. Now let us do a question related to this. So let's say our question is something like this. Our question is, let roots of quadratic equation ax square plus bx plus c equals 0 are alpha comma beta, and that of and that of ax square, not b, sorry, 2bx 2bx plus c equals 0 are, let's say, alpha plus k, beta plus k. Then find the value of then find the value of a square into b square minus ac divided by a square into b square minus ac. See, one more thing I want you guys to remember this, that whenever you see, like, the b square minus 4ac is involved in the question, so one line of thinking could be is that maybe the difference of roots would be somehow involved in the question. What I mean is that suppose, I'm talking with reference to this question only. Let us say that when you try to see here, this b square minus ac, isn't it? Basically, what is this b square minus ac? So when you try to see b square minus ac for this equation, it is a discriminant, isn't it? It is the discriminant. So one line of thinking could be that maybe in the problem the hidden part would be the difference of the roots. The hidden part would be the difference of the roots. So let me again explain what is the question. Question is simple. They are telling that alpha and beta are the roots of a given quadratic. Then they are telling that they have added a constant to both the roots. When you add a constant to both the roots, now they will be the roots of some other equation. So that equation also they have given. Then they are asking some relation between that, okay, when you compute this value, what is the final outcome? Okay. So here you can write again a note point. You can write it as a note presence of d. D is what? D is your discriminant, because question to question that D is the discriminant in problem. In problem may imply involvement or application of difference of roots. Application or involvement of difference of roots. So this I would say that you can keep it in some problems. If things are not working out, this line may give you a direction to at least initiate the solution. Right. So now let us again come back here. Let us ask here that when you see these questions, in what way you can relate this alpha beta and alpha plus k and beta plus k. Right. Think. So one thing is, if you try to calculate their sum, there you will get alpha plus k, here you will get alpha, sorry, there you will get alpha plus beta, here you will get alpha plus beta plus 2k. So again, they are not same, isn't it? Then the other line of thinking could be is product. So when you go in the product, there you will get directly alpha beta, here you will get alpha plus k into beta plus k. When you again try to evaluate, definitely they are not same, isn't it? But if you could think something like, let us see difference. When you calculate for the first quadratic the difference of the roots, and when you try to calculate the difference of the roots for the second quadratic, we can see that they are same, isn't it? In first one also you will get alpha minus beta, and here also you will be getting this alpha minus beta, right? So basically, what is the conclusion? The conclusion is that in this particular question, it is a very common question. Whatever books you would be solving or materials you would be following, definitely this question would be there. Okay. So what is same here? Here, alpha minus beta is same as alpha plus k minus beta plus k, right? Or can I say something like this also? The absolute difference would be same, right? Okay. If I square both the sides, so I can write it as what? Alpha minus beta whole square equals alpha plus k minus beta plus k whole square. And what is alpha minus beta? So let us say that for the first one, the discriminant is d1, and for the second one, the discriminant is d2. So according to our above discussion, what we can write from here? We can write d1 by a square should be equal to d2 by a square. What is d1? So we know that d1 is 4b square minus 4ac. Please see here, it is not b, it is 2b. So 2b whole square, when you will do what, you will be getting 4b square. And what is d2? d2 again is 4 capital B square minus 4 capital AC. So I hope you can get this. It is basically what? 4 times B square minus AC by A square equals 4 times B square minus AC by A square. So this 4 will get cancelled. You bring all the terms on the left hand side. Ultimately what we got? We got A square times B square minus AC divided by A square times A square minus BC, and right side what is left is 1. So answer to this question is 1. I hope you are comfortable. Okay. So let us take one more small discussion. The next topic that we have is symmetric expression. Symmetric expressions. What do we mean here? What do we mean here? So see, basically, let's say a quadratic is given whose roots are alpha and beta, right? And then they ask you to calculate the value of alpha square plus beta square. Okay. Now my question is alpha square plus beta square a symmetric expression? First thing is, what is symmetric? Symmetric is something like if you interchange, like in place of alpha if you write beta, and in place of beta if you write alpha, will the expression remains same or is it changing? So the best example or the most easiest example I could take is, think like alpha plus beta. Is alpha plus beta a symmetric expression? You interchange beta and alpha, are you getting the same thing? Answer is yes. So it is. Is alpha minus beta a symmetric expression? Definitely no. Is alpha square plus beta square a symmetric expression? Answer is yes. Is alpha square plus beta cube, alpha square plus beta cube, a symmetric expression? So think, if I interchange alpha and beta, am I getting the same expression? Sure. No. Don't say yes at least. You'll be getting what? Beta square plus alpha cube, isn't it? So definitely it is not same as alpha square plus beta cube. So it is not the symmetric expression. So I think I have given fair enough idea. So a few examples like, you have written something like alpha square plus beta square plus AB. And I'm writing alpha square plus beta square minus alpha beta. Now again, I will say that pause the video and write whether it is symmetric expression or not symmetric expression or asymmetric expression. So in the class when I asked, first one they say yes, and then they pre-assume that okay, why will ask again symmetric. So they start telling asymmetric and all. But second one also is going to be symmetric, because when you interchange alpha with beta, you will get like beta square plus alpha square minus beta alpha, which can be again written as alpha square plus beta square minus alpha beta. So answer is basically just for both, right? So let us write the theory part here. The theory is an expression an expression is called symmetric is called symmetric in alpha comma beta if interchanging if interchanging alpha and beta does not change does not change expression does not changes does not changes the expression. So example like alpha square plus beta square plus alpha beta, right? Another example you can take like anything, you can take something like let's say alpha cube plus beta cube plus alpha square beta plus alpha beta square. Again, if you change here alpha with beta and beta with alpha, you can see that the expression will remain the same. I hope you are okay on this, right? Okay. So basically, in this topic, what we are going to discuss, we are going to discuss a very important point. Now listen, the point is that any symmetric expression, right? Or we can go this way, that suppose expression is written in terms of alpha with higher degrees, like a cubic expression is written in terms of alpha, or fourth degree is written, or 10th degree is written. With the help of the given quadratic and the fact that alpha is a root of the quadratic, we can reduce that expression into a linear expression. I think it might not sound very clear. So let me put it this way. Suppose the expression is written, okay? Expression is written something like, let us say something like alpha to the power 4 plus 3 alpha square plus 2 alpha minus 5. And they are telling that alpha is a root of x square plus 3x plus 5 equals 0. So what I'm saying that all these expressions, the expression what is written over here can be reduced into this form. Means this expression what is written on the left side is going to be same as that, when it is going to be equal to a alpha plus b, like a and b value I have to calculate. But what I mean is that this higher degree expression can be reduced to a linear expression. It can be reduced to what? A linear expression. I hope we are clear on this. So let me put it this way. There is expression given in terms of alpha. Alpha is a root of the quadratic. Our target is to show that this big expression what is written on the left side is going to be equal to a alpha plus b. Then find the value of a and b, right? So this I'm giving as a homework. You also do some some Google or the books, do some self studies, try to figure out, do your own analysis, and then in case if you're getting, you can let me know by commenting, or else I'll be discussing this in the next lecture. Till then, see you, take care. Thank you. Bye bye.